Okay, so this is the project we're going to be working on today. Hopefully we'll get this finished. Just kidding. Actually, so this is a project I actually helped work on. This is at Lawrence Livermore National Labs. This is the NIF module. What you can see, this little blue area right here is a big, huge sphere. And all of these units that you can kind of see here are big, huge laser modules that they shoot these lasers into like a little tiny area inside this sphere to create like, fusion, basically a black hole. They're trying to create new types of fusion. And the reason I'm showing this picture is think about how complicated this 3D model is. And there's actually a 3D model of this. And I was working with them on some of the projects for this. So we're going to be talking a lot about organization and how to keep things organized and working together and linked and all that kind of stuff. And this is the reason why your assemblies might not be this complicated, but one day they might. And how do you organize something as complicated as this? Just a fun little fact, in one of the Star Wars movies, they actually used the NIF module as the engine of the Enterprise. I just thought that was kind of cool that they used that in the movie. So you've actually probably seen it if you watched the movie. So fun fact. Okay, so the first thing we're going to do, and like Umair mentioned, if you have any questions as I'm going through, please feel free to post them into the Q&A, and he's monitoring those and will either answer them or bring them to my attention to have those answered. So I'm going to talk about bodies and components. Okay. If you've been using Fusion, you've probably heard both of those terms. What's the difference between a body and a component? And being fully transparent, when I first started learning Fusion, this is what confused me the most. I didn't understand when do I use a body? When do I use a component? Why should I use them? Well, it took me a little while to understand, and the best way I can explain it to you is if your objects are going to work together or interact with each other, they have to be components. So, for example, a robotic arm, or a CNC machine, or a 3D printer, or a vise, or something like that, where these components are moving and interacting with each other, they have to be components. If you're just making a single object like a little stand for your phone that you're going to 3D print, that could be a body, right? It's just a single thing. So, the best advice I could give you is always, always, always create everything as components from now on. Just get it in your head to always create things as components. And I'm going to show you why. There's many benefits for creating things as components. So I'm going to do a really quick demo here. I'm going to start by creating bodies first. And here's Fusion right out of the box. I come in here and I create a sketch. I draw a rectangle like so. And I'm just going to draw, I'm not worrying about dimensions or anything like that in this example. I'm going to go ahead and extrude this. And you'll notice that it created a body. And it kind of looks like a little cylinder icon. I'm going to go ahead and rename this. I'm going to call it block. Okay. Then I want to create another body. I'll go ahead and extrude this. I'll just do that like so. I'll do it symmetrically. And so now I have two separate bodies. I'll call this one rod. Okay. Now, first of all, if I try and click and drag, I physically can't move these bodies around. I want to create some kind of motion. I want to show that this rod can slide through that block. Well, that's under the assemble menu. And we need to create some kind of a joint. Well, when I do that, you'll notice I get a warning. There's no components in this design. So that's the very first thing. If you want to show how things interact with each other, they have to be components. So you might as well start with having them be components. So that's the first thing. The second reason I like using components and not bodies is if I came in here and said, let's go ahead and move this block. I'm just going to move it up and move it back a little bit, for example. And then I turn on its sketch. Notice where its sketch is at. Now, the sketch still drives changes to that block. So you'll notice I moved the sketch edge there and the block updated accordingly. This is really a simple example. Think about a more complex assembly. This could get confusing really quick where the sketch is nowhere near the body and you make a change and a body somewhere else far away updates accordingly. That could get really confusing. Okay. And then the last reason I don't like using bodies is there's no structure in the timeline. And this will make more sense as I show the component example, but everything is pretty much linear in the timeline. So I created a sketch, I created an extrude, I created a sketch, did an extrude, and then did a move. And it's just pretty much linear. Okay, so now I'm going to do the exact same thing, but this time I'm going to use or create components. Okay, so I'm going to come under here and say new component. And it is one extra step, basically. So you'll notice here, I can give it a name. So I'm going to call it block. And I get this little icon right here. And I'm going to go ahead and expand this open so you can kind of see what this looks like. And one of the things that I like to explain components as is you can kind of think of a component as like an envelope of information. Everything that has to do with that component is going to be inside that envelope. So right now you can see inside this block component, it has an origin. Well, watch what happens when I create a sketch. So I'm going to go ahead and do that exact same rectangle. Okay. Notice inside this component, there's a sketches folder with a sketch in it now. And watch what happens when I do the extrude. Now there's a bodies folder inside this component. Now, typically your component is kind of like folded up, so it looks like this, but all of this information, the origin, the sketch or sketches, and the body or bodies are all inside this component. Okay, and this will make a little bit more sense as we move along. So now I want to create a new component called rod. So I'm just going to come in here and create a new component. I'll call it rod. And you'll notice that this other component kind of ghosted out. And that is because you'll notice there's the block and then there's the rod and there's this little radio button. This is the active component. We're working on one component at a time. Now I can still reference this other component. You can see I can select faces and edges, etc. So for example, I could create a sketch on that front face. I'll go ahead and extrude just like I did last time. I'll say symmetric. And in the rod, it has its own origin, its own bodies, its own sketches, etc. Okay. Now, if I click on the radio button next to block, you'll notice the rod ghosts out and the block is now active. If I click on the radio button right now next to unsaved, and that's because I haven't saved this file yet. If I called this like demo, it would say demo, but I'm going to go ahead and activate the top level. Now you notice both of them are no longer ghosted out. And if I grab the rod, you can see that I can move that around, whereas I couldn't do that previously. Also, if I grab this block and I say move, just like I did before, if I move that block up and I move it back and I say, okay, I'm going to go ahead and expand this open. Remember, I said this is kind of like an envelope. So I grabbed that envelope of information. So I moved that whole envelope up and back. So its origin moved. You can kind of see that here. The body moved and the sketches moved. So if I turn on the sketch, you'll notice that the sketch is where the body is. It's not over here in space like this first example that I did. And then probably my favorite reason for using components is because of the timeline. So watch what happens when I activate the rod component. It is only showing the features that have to do with this active component. I created a sketch and then I did an extrude. So for example, if I came in here and said, let's fillet this edge, you're going to see a fillet feature in the timeline. Let's go ahead and activate the block, and you don't see a fillet feature in the timeline, okay? Because there isn't a fillet feature on this active component. If I were to create another sketch, let's just say over here, I'll go ahead and revert the position real quick. I'll draw a quick rectangle. Let's just say we're doing a dado or something down here. I'll extrude that all the way through. I'll say, okay, you can see I now have the original sketch, the extrude, a secondary sketch, and an extrude. And then maybe we like chamfer these edges or something like that. You're going to see these features appear in the timeline just for the block. If I activate the rod, you don't see those extra sketches, those extra chamfers, or anything like that. Now, if I activate the top level, you are going to see all of those features because now it's showing everything that was used to create everything below the top level. So you're going to see all of the features. So the component really does help you with organization and keeping track of things. Okay. Now here's a cool little trick. I'm going to turn off that sketch that can help you even more with visualizing things. So under the inspect menu, there is a command in here called display component colors. I'm going to go ahead and click on that, and you can see it basically made these like pastel colors, and one's kind of like an orange and one's kind of like a green. And you can see down here in my timeline, we have like some orange and some green. And that's basically showing where in the timeline these parts were created or these features were created. So it's a really visual way to kind of see, and you can even see it over here. Here's the green for the block. Here's the orange for the rod, for example. Okay. And it is a toggle, and there is a shortcut key. And the reason I'm pointing this out, it says Shift N, is sometimes you'll be working along, and like, for example, you might be like renaming your part. I'll just start calling this like something or whatever. And you might accidentally, want to do like, you want to call it something like normal or whatever. And you start hitting Shift N to type in normal, and then your parts change. And it's because you accidentally clicked out of your part, that you were naming, and you hit Shift N, and it created this little toggle here. So all you have to do is come in here and display component colors or hit Shift N to toggle it on or off. So let me show you like a real world example. So here's like a full assembly. If you take a look at my timeline, I'm going to scroll through. This is a fairly lengthy timeline, lots of features, right? But you'll notice no errors, which is really good for a large assembly like this. And the reason for that is because they're components. It's much easier to control your design as components, whereas if things were bodies and stuff like that, it's much easier to have errors and mistakes and reference issues and stuff like that. But with components, it's much easier to control. But then I can also do things like, for example, you can kind of see how things are organized over here. So you can kind of see a couple different icons. So for example, this basket looks like a single component. And then you can see something like this base looks like multiple little cubes. So that has multiple components underneath it. Okay. Whereas the basket is just a single part. So let's take a look. For example, you can see, and I name things so they make sense to me. So you can see I have cutter assembly. So there's, and you can tell, even though the icon shows that it's assembly, I name it as cutter assembly. And underneath that, I'll have multiple components. Same thing with like this piston assembly. So here's the piston and the spring. So let's go ahead and just activate this piston assembly. And you can see how it kind of ghosts everything out. And here's another little tip. If I right mouse click on the piston assembly, I can isolate it. And that basically turns everything else off. Well, now notice my timeline. It's much shorter. Okay. I didn't have to scroll across to see all the commands. These are the commands necessary to create these parts. In fact, if I were to come in here and activate just the piston, notice my timeline got even smaller. So these are the commands necessary to create just this part that you see up here. So for example, I'm going to go ahead and isolate just that, and let's just step through. So I'll just kind of step forward. So I do a revolve. Let me turn off this guy here. So I'll back up. Oh, sorry, hit the wrong button. Um, so I start with a sketch and I do a revolve. So that's my sketch creates this little revolve. And then I combine some stuff together and do a pattern. I do a fillet, do another sketch, and I end up, removing or cutting away or extruding away that little feature right there. If I activate this piston assembly here, I can jump to the end and you'll see, let me go ahead and unisolate everything here. So you can see the spring, et cetera, et cetera. So, and you can see in the timeline, for example, the coil that was used to create that. So it's using components allows you to visualize and organize things very easily. Um, and keep your timeline much easier to manage. So if I were to activate the basket, here are all of the features that were used to create this particular shape right here in the timeline. Okay, hopefully that makes sense. So key things to just cover here really quick. Always use components. Just get used to it. Just create components from now on, even if you're creating a single part. That way it's ingrained in your head. Okay. There's so many pros to using components. My favorite one is it's so much easier to figure out your timeline and keep things organized. And um, I like the fact that you can organize in your browser very easily with components, and you can create sub-assemblies, et cetera, et cetera. So, okay. Um,
Hey Brad, there's
yeah,
a quick question.
sure.
Do you typically use your as-built joint to help keep your components in place all the time?
So that's a really good question. We're actually going to talk about that in the second session. But we're actually a little bit of both. When I start talking about top-down versus bottom-up design, the as-built joints are going to come into play there. So the question is, basically that we have joints and we have as-built joints. As-built joints, I'll just give you kind of a little bit of a high-level overview, are really handy when you're designing the parts where they belong. So for example, when I was designing this a pencil sharpener, I started with the base and then I created the second part, then I created this part, then I created the top right where they belong. Then I could use the as-built joint and said, this part revolves around this part, for example. It's a great, great command. If I was using bottom-up methodology, you design one part at a time and then you have to assemble them together, you would have to use the joint command. And again, I'm going to be talking about that. I have a slide that shows it and everything like that. So yeah, we'll talk about that a little bit more in depth here in a moment. So Okay, so how do you go about creating components? Now that I'm saying you must create components, how do you create them? Um, so there's many different ways. So under the Assemble menu, you'll notice New Component, okay? Under the Create menu, the very first command is New Component, okay? If I right mouse click in my browser, you'll see New Component. And I will share a tip with you. I use this one 99% of the time. This is my favorite way of creating, and I'll show you why here in just a moment. Also, what I like to do as a reminder, a mental reminder for me, is I like to put this new component in my toolbar as a mental reminder. So I'm in my Create menu. I'm going to hover over these three little dots and say Pin to Toolbar. And you can see that it added that new component to my toolbar. And I'm just going to click and drag. And you can see I can move it to the very beginning of my toolbar. And that to me is, it's even before my sketch. So just a visual reminder, oh, I want to create a component even before I create a sketch. So if you want to do that, you can do that also. Okay. So let me show you why I like doing the right mouse click for creating a new component. So you can actually create like a whole assembly without even creating a 3D model. So let's say, for example, I'm going to create a bike. So I'm going to right mouse click here and say new component, and I'm just going to call it bike assembly. And it just created this bike assembly. Then I'm going to right mouse click on that and say new component. And I'm going to call this front wheel assembly. And notice what it did. So it created underneath this, kind of like in a little ladder diagram, it created this front wheel assembly. Now, if I right mouse click on the bike assembly again and say new component, I could say, rear wheel assembly. And it's going to create a rear wheel assembly underneath the bike assembly. So you can see how it's kind of at the same level as the front wheel assembly. And if I right mouse click and say here, and I say sprocket assembly, it's going to create a sprocket assembly underneath the rear wheel assembly. And I'm just going to keep going along here. Now I'm going to just create sprocket 1, sprocket 2, and sprocket 3. So let me go new component. I haven't even modeled anything yet, but I'm basically building kind of the structure of the bike, right? So we've got the bike assembly, the front wheel assembly, rear wheel assembly. Underneath that, we have the sprocket assembly, and underneath that, we have the sprockets. And now I can click on the, activate sprocket 1, create my sketch, and I'll just, I'm just going to draw cylinders really quick that kind of simulate the sprockets, right? So there's sprocket 1. I could come in here and activate sprocket 2, and I can reference this guy. I could create a sketch on it, create a circle. This is sprocket 2, let's just say, and then activate sprocket 3. So I spent a little bit of time, creating the structure, and now I'm coming in and building the actual geometry. Now, do you have to do it this way? No, you can, but you don't have to do it this way. Me personally, what I typically do is I'll create 4, 5, 6, 7 parts in one level, and then I might start organizing it. I might be like, let's say I'm designing a 3D printer, right? And I start designing the frame, and I'm just extruding parts and assembling parts, and then I might come in here and come in here and say new component. I'll say frame assembly or something like that, and then I'll just start dragging components, and I'll show this. I'll start dragging components into that assembly. And then I might create another assembly called hardware, and I'll drag hardware into that assembly. So you can create these any order that you want. Um, That's how I typically do it. But some people will actually do it this way also. They kind of build the, like almost like a skeleton of it, sort of, and then start designing the individual parts. Okay. Now, what's cool about this is, let's say, Umair was like, hey, you know what? Let's make this a recumbent bike instead of a regular bike. And so that means we need to move the sprocket assembly to the front wheel assembly. Well, I can just drag. I'm just going to click the sprocket assembly and I'm going to drag it on top of the front wheel assembly. And now the sprocket assembly with all three sprockets is underneath the front wheel assembly. I could grab sprocket 1 and drop it into the rear wheel assembly. And now just sprocket 2 and sprocket 3 are up here, but sprocket 1's under the rear wheel assembly. So you can reorganize your assembly structure really easily just by dragging components around. And that's another great reason to use components. Okay. I could drag the sprocket assembly back to the rear wheel assembly, drag sprocket 1 back into the sprocket assembly, and we're back to where it was. So hopefully that makes sense. Okay. Now, why do I like the right mouse click? Let me show you kind of the same example, but not using the right mouse click. So I'm going to say new component, and I'm going to call this bike assembly. And notice it says parent and name and all this kind of stuff. We'll get to that here in a second. So I'm going to say bike assembly. Now I'm going to say new component, and you'll notice it says parent, one selected, and it says bike assembly. So it basically used the last one that I created. So I'm going to say front wheel assembly. Okay. So now if I say new component and I type in rear wheel assembly, where's it going to go? It's going to go underneath the front wheel assembly. So the parent is going to be the front wheel assembly. And you can kind of think of this as being a child. So if I hit OK, it's going to go underneath the front wheel assembly. Hopefully that makes sense. I'm going to undo that. So if I didn't want that to happen, so if I say rear wheel assembly, I would have to clear this out and come over here and click on bike assembly and say okay, right? Which isn't a big deal, but I had to move my mouse or whatever. Whereas by, right clicking and saying new component, I'm saying this is the parent. If I right click on this guy and I say new component, I'm saying this is the parent. So I think it's a quicker way of saying new component. I told it the front wheel assembly is the parent. So I'm not having to move back and forth or whatever to do that. So that's why I like using the right mouse click. I just think it's faster. So, okay. Um, I'm going to jump back to this pencil sharpener assembly and activate the top level. I already showed this. I just want to reiterate it really quick. To activate components, there's these little radio buttons next to it. So if I click on the radio button, the base is now active and the other ones are kind of ghosted out. If I activate the basket, now the basket is active. And like I mentioned before, if I activate one of these, you can right mouse click on it and say isolate. I'll do this quite often. I'll say isolate, and it basically turns all of the other parts off and just makes it easier to work with just, what's on the screen. I can see all the features in the timeline. And then I can right mouse click and say unisolate when I'm done with that. So that's just a quick tip on activating components. And then when you're kind of done with that, I just click on the radio button at the very top level assembly, and that makes all of these components active. I'm basically saying At this level, everybody underneath is active, and that's why you see nobody's shaded out. So, or ghosted out, I should say. Okay, let me close a couple. Actually, I'll use this one. Um, let's go back into new component and talk a little bit about this dialog now. So you'll notice you'll see external and internal, and by default, it's set to internal. So what's the difference? Well, internal is if you're creating mostly like one-off designs. So for example, like this pencil sharpener, you know, I'm probably not going to reuse any of those components in like a sofa, for example, right? But let's say my company, let's say I design pool tables and I have a pocket, you know, like a corner pocket and a side pocket or whatever, I might end up reusing those pockets in multiple different table designs. Even though the tables might be different, I might be reusing those pockets. So I might want to create those pockets as what we would call external components. So in this example, I'm checking external. And you'll notice when I do that, it allows me to give it a name. So I'll give it a name. I'll call it pocket, right? And then it's allowing me to pick a location. So it's gonna, when I create this component, it's gonna save it for me automatically into a particular location. And in this case, I'm in my webinar slash assemblies webinar location. Okay. And then I can also, you know, pick a parent and all that kind of stuff. I'll just leave it at the top level. In this case, I'll say okay. And now I'm just going to go ahead and create a quick pocket just for fun. Um, I'll just make it a circle just to speed things up. And you'll see what will happen here. So I'm going to go ahead and extrude this. Very boring pocket. And you'll notice this little link icon that it's creating. Okay. And I'll go ahead, even though I have, let me go ahead and remove these guys out of here. Let me just remove those. And I'm just going to save this. And when I expand open, you're going to see that it's going to create this pocket as its own individual component that we're going to reference. And I'll show an example of this here in just a second. So here is, for example, this wine cabinet that I modeled. And I've got, lots of wooden parts, panels and rails and stiles and stuff like that. But then you'll notice like these handles have these little link icons. So these are external components. So these are things that are probably going to get used in other designs. And what's cool about external components is if I made a change to one of these, so for example, let's take a look at this left hinge right here. I'm going to go ahead and open this hinge by itself. And here's what it looks like. And this is the standard hinge we use on all of our designs or whatever. And maybe we make a change to it. So I'm going to go ahead and let's just punch a hole through it right here. Let me turn on the sketch so we can see it. So I'm making a change to the original model, okay? And I'm going to go ahead and save this. So I basically only have like one file of this hinge, but then it was used in this wine cabinet. And now you'll notice that I get all these little warnings saying the design contains removed components that are out of date and all this kind of stuff. So I'm going to go ahead and click on this, update the component to its latest non milestone or whatever. And so it will update those and you can see how these hinges now have the hole going through them. right? And any other design that I had that used this hinge or this style hinge would update also. So instead of me having to do it one at a time, and remembering having to do that, uh, basically I'm using a referenced hinge, and I made a change to that one hinge, and my assembly updated accordingly. So external components are really handy for things that, you might use over and over again, like hardware or like that pool table pocket example that I was talking about that might be use in other pool tables, whereas the table itself might look different, right? But you want to reuse existing components. So that's where you would use the external component. And it basically just allows you to save it into your project, like you see here. And then you would just right mouse click and say insert into current design. And here you can kind of see it's coming in, and you'll notice that little link icon. So, I'll just say okay, so you can kind of see what this looks like. And I've just brought that pocket into my design, and it's linked. And what that means is I can't come in here and add a fillet or a chamfer to the edge of this pocket because it's being referenced. The master is this pocket over here. So if I tried to come in and say fillet, and I can't click on that edge, you'll notice it's not letting me. Okay. If I wanted to change this model, I would actually have to open that pocket, make the change here, save it, come back to my wine cabinet, and now you'll notice it's saying, hey, it's out of date. So I could come back and get the latest version, or I could replace this component with a different pocket if I wanted to, but I'm going to say get latest version. And now you can see I just got the latest version that has the updated fillet on it. So that's the difference between an internal and an external component. It's a great way to kind of control things to change or not change, things that are going to get used in other assemblies. You would want to use external components. Hopefully that makes sense. I don't know, Umair, if there's any questions or comments about that.
There are some. So
Okay.
Dan was actually asking, what would you call the very top level of, remember the bike example you brought up earlier, but we can
Yeah.
use this file. But what would be
Yep.
the very top level of that bike, and what would that level be typically used for?
So that's a good question. I don't know if I still have. Yeah, so here's a good example. So I created bike assembly right here. You could call, a lot of people call this the root level. Now, if I were to save this, I would call this, you know, um, you know, recumbent, whatever, bike or whatever. Um, it's going to be called recumbent bike. And then here's my bike assembly and everything underneath it. So this is how I typically kind of organize things. Now, this could have been my top level assembly, and then this could be rear wheel assembly, and then everything underneath that. But I kind of like to have this level be my top level, and then I would almost call this like the root level. And I don't know if that answers the question, but I almost kind of call this the file name, if anything. But you'll notice the icon shows it as like an assembly. So the I don't even know if the way I do it is the preferred or the correct way. This is almost like a sub-assembly of this. So it's really up to you. You could literally say that this is the bike assembly right up here, and then everything starts underneath it. I could probably get rid of this and have front wheel assembly, rear wheel assembly, like so, underneath those guys. So if it'll let me. Yep. And get rid of, let me just remove that out of there and have it like this almost. I could definitely do it like that. That's a really good question. So there's I don't think there's really a right or wrong way there, but I typically create almost like a starting assembly and then go underneath that from there. So now there is, I will show this since we're here. I know we're running a little bit short on time, so I'm gonna have to kind of cruise through. You'll notice this little anchor icon. I'm gonna probably talk about it a little bit more in the next session. And you'll see the anchor icon exist here. This is fairly new within like the last year. And basically what that's doing, it's creating rigid groups for you automatically. In fact, I think I'm going to talk about it more um, next session since we're running a little bit short on time. So don't let me forget that. But I'll talk about this anchor icon, what that means. So, okay. So the next thing I want to talk about is the top-down versus bottom-up design. So I need to um, tab back to, give me just a second here, my slide deck real fast. Hopefully I can get this to present correctly. Okay, so the difference between bottom-up and top-down. Okay. I'm going to start with top down. This is, with Fusion, we can actually do both. Okay. Now, what I've been kind of showing is this top down assembly. So, for example, that pencil sharpener was a top down assembly. So, new components are designed within the same file as the assembly. New parts are created directly around the existing assembly components. Like I mentioned, I started with the base, then I created the middle, then I created the clear part, then I created the top, and I used all of those parts to help me design the next part. And in Fusion, these components are referred to as internal components. And so you can kind of think of it as you're in one design, you've got multiple components, they're all assembled together, all in one design. And I even kind of show that in that bike example. I started creating an assembly structure, and then I started creating the individual sprockets, right? Okay. Then there's also bottom up assemblies. And this is kind of like Inventor, SolidWorks, Creo, those kind of tools sort of use this assembly structure. And that's where each component is created independently in its own separate file. Okay. Then the designer assembles these individual components or individual parts into a larger assembly using a separate assembly file. So they design part one, they save it. They design part two, they save it. They design part three and they save it. Then they create what's called an assembly file and they bring in part one, then they bring in part two and they say join those two together. They bring in part three and they join that part together, etc. And in Fusion, these are typically called external components, kind of like I showed with the wine cabinet with those hinges and handles and stuff. Now there's pros and cons with both methods. So the bottom up advantages, I have some notes here, so I'm looking over my notes. They allow you to reuse individual components in other projects, kind of like I mentioned with the pool table pockets, which allow you to promote design efficiency and consistency. Like I showed, you can't modify a model in your design. You actually have to modify the original model, and that propagates through all of your other designs. You can manage each part individually, simplifying updates and modifications without affecting the entire assembly. And then this approach is particularly useful when working on complex designs with numerous interrelated components. It kind of helps organize that. With the top-down assembly advantages, it offers rapid design iterations and quicker prototyping. You don't have to worry about, all of the interrelationships and all that kind of stuff. They can build new components while considering the rest of the assembly, ensuring proper fit and alignment with the existing parts. And this is huge. When I was in federal aerospace and defense, I went to all the big, huge customers. You don't know how many computer screens had post-it notes with dimensions written on them because, they would design part one and then they'd have to design part two. Well, they needed information from part one to design part two. And that, they had to know what size was that hole and what dimension, how far from the wall was it. They had to write all that stuff down. Whereas in this method, you just project the geometry or you reuse existing geometry and stuff. It's so much easier in top down to do that. So again, there's pros and cons with each method. So depending on what you're designing, bottom up might be better for you, or top down might be better for you. So we'll leave that up to you. You can try both methods and see. Okay. Um, so let me show an example really quick. So here is like a mechanical vise. It's got some joints and stuff like that. And I want to create some soft jaws that's going to hold something in here. And this is going to be the top down design. I want to create a part really quickly. So I'm going to come in here and say new component. It's going to be internal. I'm going to call it soft jaw, like so. I'll create a sketch on this face right here. I'll just project that face. So I'm just clicking on that face and you can see it's projecting that geometry. And now I can just reference that. I'm just coming over here and I'm going to grab that point there. I'm going to hover over that point there and just, come out a little bit. Let me throw some dimensions on here really quick. So that's, 87. Let's make this 17. And maybe I just put like a quick arc or something like that. I'll do a 3-point arc. Something like that. And maybe I throw a dimension on there. And let's just make that 900 or whatever. Okay, finish my sketch. So literally in a few seconds, I now have, when I extrude this guy up, I have a curved soft jaw. Let's just make that 5 millimeters thick, right? That has the holes in them already in the correct location. If I were to come in here, maybe insert a fastener really quick, let's just do this just for fun so you can kind of see what we can do here. I'll do, let's just do a socket head cap screw. Um, let me do this guy here. I'll click there. I can visualize from the side, see how far down I need to go. Let's just do something like that. Say okay. And I'll do a quick as-built joint. So I'll just come in here and say rigid group. I want this to move with that jaw. I'll say okay. And now when I move that jaw, my soft jaw and the bolts all move with it in just a few seconds, right? I was able to create this. I could mirror it to the other side. But that is top-down design. I used information from the existing model to help me create this particular soft jaw. And you can see how quick and easy that was. Okay. I didn't have to create it in a separate file, come over here and take measurements and figure out how far apart these holes were, what size they were, write that down, et cetera, et cetera. So hopefully you saw the benefit of top-down design. Let's do a bottom-up style design. So here's, and again, we're trying to move here quickly. I have a whole bunch of individual components, right? So here's the base, and then I'm going to come in here and basically insert this swivel into my current design. I can see it's like over here somewhere. Um, and I'll go ahead and just do a quick joint. And let's just say that guy lines up with this guy. And I want that to be a revolute joint. And we can kind of see what that looks like. Um, and we can see that that came in. You can see how it's linked or whatever. And if I grab that, we can see how that can move around. And I can keep working along. I can come in here and insert in this body. And let's do kind of the same thing. I'll just do a quick joint here. And we'll spend more time on how I'm doing this. But here's the key thing. I'm inserting this design and it actually has existing joints. I don't know if you can kind of see those. It already has existing joints and it's bringing those assembly relationships in. Let me go ahead and change this to a revolute joint and I'll just, oops, sorry, not as built joint. I want to do a regular joint and I'll just say that guy with that guy here and flip that around. I'll say okay. And you can see how it updated all the other joints and how this kind of rotates around and stuff like that. And what's cool about this, I'll go ahead and say okay. If I could continue assembling this, notice, this assembly here. Let's say I open this, you know, 6 months from now or something like that. We make a design change and decide, here's a big chunk of metal. Maybe customers want to have this as a tray or something where they could store, nuts, bolts, or screws or something. So let's just make an indentation in here. So I'm just going to create a quick rectangle like so. Let's turn on my sketch and extrude that down really quick. Some distance, let's just say, -10. I'll say fillet. I'll do a quick rule fillet on that extrude. And let's just do fillets only. And let's just do maybe a 2 mm fillet. Okay. And I'm going to go ahead and save this. And if I come back to this design over here and update that, my design now updates, right? So I didn't have to make changes to this design. The linked design that was inserted in here updated. If I had done this as a top-down design and it wasn't linked, I wouldn't have this capability. I would have to have come in here and made that change myself. So again, there's pros and cons with both. Okay, that's drinking from the fire hose of information. I'm going to pause here, open it up, Umair, for any questions or comments that you wanted to share.
Yeah, hey, there is a really good question, Brad, that Neil asked about how you grab the midpoint for that center rectangle that you just drew.
Okay,
Yeah, would
yeah,
you mind maybe possibly repeating that?
sure. Yeah, let me back up here. Um, Oops, okay. So what I did is I created a sketch. Um, And then when I said rectangle, I did what's called a center rectangle. And then if you hover over edges, you'll notice when I get near here, you can kind of see how it's catching to that edge. And right there, there's a little triangle. And if I move, it's probably really hard to see. I wonder if I rotate in 3D, if you can see a little bit better. But it's creating what's called a snap guide. And so all I did was find the center and it's creating a snap guide like so. And I do the same thing here. I hovered for about half a second and then it's creating a snap guide. You can kind of see it in that white shadow. And there it's found both of them. And you can kind of see it snap right there. So I just clicked and that's the center of that horizontal edge and that vertical edge at the same time. Now, it is not it's not a physical constraint. It's not a midpoint constraint or anything like that. It's literally a quick sketch thing. So what I mean by that is I can grab this and move it around. It's not physically constrained to the midpoint of that and the midpoint of that. It's just a quick guide, basically. If I wanted it to be perfectly centered, I would want to use a constraint of some kind. So just FYI. It's
Perfect.
just a cool little sketch trick. So yeah, good question.
Thanks, Brad. I think we were able to answer quite a few other questions on the chat. So again, if you have anything, we can still hold on here for a few more minutes if you have any questions. We'd love to answer them. And then if you are, and while you are maybe possibly thinking about those questions, just want to remind everybody that this is like, Brad says, a three-part series. So that was part one. Part two, we're going to get more into joints, and part three, we're going to get into some more other advanced assembly related topics. So make sure that you are registering for all three of them. You will get emails. If you're registered for this one, you'll probably get an email to register for the next ones too. But hey, tell your friends, tell everyone you know, if they would love to kind of follow along. It's never too late. We'll upload this recording here to, excuse me, to the website, and that way they can always get the first part of it and then follow along for part two and part three. So yeah, thank you everyone for joining us today. There's going to be a few more bits and pieces of news and information that's going to come your way about this topic, assembly specifically. So keep an eye out for that, and we'll cover some of that news in our next sessions as well. So again, thank you everyone for being here. I don't see any other questions. Feel free to drop them in on your way out if you'd like, and we can even answer them next time. But yeah, if not, thank you for making the time. Thank you all.
Thanks, everybody.